All right, it's time for us to go ahead and move into the second half of Module 3 here. Quick little caveat. As we go through the final 3 lectures in Module 3, there is a huge thing you need to know. We are going to be looking at a lot of formulas. None of the formulas in these last 3 lectures are ones that you need to memorize. The formulas contained in the last 3 lectures of Module 3 will all be given to you on Exam 3, so you do not need to memorize them. Kind of keep that in mind as we go over. If you find yourself feeling overwhelmed, just keep that in mind. Now, that does still mean that the earlier identities from the first half of Module 3 and the ways in which we use them are things that you need to memorize. It's just these final set of 3 lectures. The formulas here are ones that are going to be provided to you. I'll talk a little bit about these different formulas and which ones are probably really good to memorize for later classes, but please keep in mind that you will be provided these formulas on your own when you take Exam 3. All right, with that out of the way, let's go ahead and dive into things here. In section 2.4, we're going to be taking a look at what are known as the sum and difference formulas. The idea here is that we're going to look at a handful of formulas that involve the sum and difference of specific angles and how we can split that up into different values that are much more easily evaluated. And that's the key idea. We want to evaluate certain trigonometric functions. We're also going to use this concept to verify a handful of identities, specifically the cofunction identities, and we're also going to see how they can be used to solve certain types of trigonometric equations. So with that out of the way, let's go ahead and talk the basics here. We need to actually discuss what this sum and difference formulas are. So we have them for sine, cosine, and tangent. These are the collection of what we call the sum and difference formulas. As I talked about, these are dealing with the sum and difference of angles inside of the trigonometric functions. So you'll see here that if we have something like the sine of an angle u plus the sine of an angle, plus the angle v, we can split that up into sine of u cosine of v plus cosine of u sine of v. Similarly, if it was to instead be a difference of angles inside of sine u minus v, we keep pretty much the exact same setup, but switch from positive to negative, or rather from addition to subtraction for those middle 2 products here. It's sine of u cosine of v minus cosine of u sine of v. For cosine, it's a little bit different. Cosine of u plus v becomes cosine u cosine v minus sine u sine v. And by the same token, cosine of u minus v is cosine u cosine v plus sine u sine v. Now, I previously mentioned in this video alone that you do not need to memorize these formulas. That said, these first 4 formulas, the sum and difference ones for sine and cosine, are probably good ones to commit to memory for later courses. If you're going on to take calculus, these are ones that you'll probably want to have handy for some of the work that you'll do there. These ones have pretty easily identifiable patterns as well. The sine always turns into sine times cosine plus cosine times sine, and it's always uv, uv. The sign between them, whether it's addition or subtraction, always matches with whether we're adding or subtracting the angles in the original sign. By a similar token, for cosine, it's always cosine cosine, sine sine, and it's always uv uv. You'll notice that the sign between the 2 products is always the opposite of the sign inside of our original cosine. Here it was u plus v, and here we have subtraction taking place instead. Now, they include the sum and difference formulas here for tangent of u plus v and tangent of u minus v, and they have these expressions here. I would say that the vast majority of the time, you're not going to end up using these, because if you want to find these specific values, it's usually easier to switch to sine and cosine, use the quotient identity to find those, and then come back here. It's not to say that you can't use this, but one of the things that I find students usually do is if they have this along with these other 4 that they have to find, they're usually going to focus here and then use sine and cosine and the quotient identity to find the values for tangent. Now that we've done this, we're going to actually see how they're applied. And this is something that I alluded to much earlier in the semester. When we first started talking about trig functions, notice that we limited ourselves to very specific angles that showed up on our unit circle. When we had pi over 6, pi over 4, pi over 3, pi over 2, 0, and any of their multiples or any additions of 2 and pi to those angles. Those are the ones we were capable of handling, the ones that had well-defined values that we could verify. But now, with the sum and difference formulas, we can handle all sorts of different angles that aren't necessarily ones that we're used to. Let's talk about one specific example. Let's say that we want to find the exact value for sine of pi over 12. In this case, to find the exact value for sine of pi over 12, we're going to make use of the fact that pi over 12 is the difference of pi over 3 minus pi over 4. So in this particular case, we can rewrite sine of pi over 12 as sine of pi over 3 minus pi over 4. Pi over 12 is equivalent to that difference, so it's a simple substitution. We're just swapping one out for the other, like we did in a previous lecture. Anytime we have two equivalent expressions, we can freely substitute one in place of the other. And now that we have this, we get to make use of our actual, formula for the sine of a difference of two angles. Let's go ahead and pull over to the notepad. In this case, we remember that for sine of u plus or minus v, the formula is always the same. It's sine of u cosine of v plus or minus, already slipping up. This will be cosine of u sine of v. So in this particular case, we have the difference variant. So ours is sine of pi over 3 minus pi over 4. These are now our u and our v respectively. This is sine of pi over 3 times cosine of pi over 4. We match the sign in between, so this will be minus cosine of pi over 3 times sine of pi over 4. And then from here, we just need to substitute in the known values for these different trig functions. Sine at pi over 3, that's going to be square root of 3 over 2. Cosine at pi over 4, this will be square root of 2 over 2. On the other side, cosine of pi over 3 is 1/2. And sine of pi over 4 is square root of 2 over 2. We'll clean this up with a little bit of arithmetic. These two are both under radicals, so we can rewrite them as the radical of their product. So this will be square root of 6 over 4. And over here, this will be square root of 2 over 4. Or written as a single expression, square root of 6 minus the square root of 2 all over 4. We cannot do any work to simplify this further, so this remains our final answer. In this particular case, while these two are both under a radical in the numerator, the fact that this is subtraction and not multiplication or division means that they cannot be combined. So we simply leave our answer in this form that you see here. This type of technique can be expanded to finding the sine, cosine, and tangent of lots of different angles. And we'll talk a little bit in the next video about how to figure out how you should split things up.